John, I'm looking forward to your talk. Thank you.
Okay, thank you. I'll start off with the obligatory, everyone can see this, right? So what I want to do over the next half hour is to sort of think a little bit and make you think about AI, where it's going, where it could go, and some of the issues that it raises, which are perhaps different to the other kinds of tools that designers have started to use. And to get a better handle on this, what I want to do is start off by looking at what are the capabilities that AI has been generating that are of particular interest to designers. AI has become a very big area. It started, the idea was in the 1950s, so it's been around for a while in the computational world. So the sort of things that are interesting are which of the capabilities. So the first one is, of course, reasoning, that's where AI sort of started. The notion that you could take the reasoning that humans use and build computational systems that mimic that. Of course, it turns out you can do amazing things with that, but not enough. So one of the other areas where we see really very significant advances, which again mimic humans, is in vision. Now, just as in reasoning, we can build computational systems that out-reason humans, so we can build in AI vision systems that can see things that humans can't. I mean, you may not like the idea, but a satellite 160 kilometers in the sky can read the number plate on your car, and I'm told can actually recognize you if you look up. That's way beyond any human's capability. One of the other areas which doesn't sound like it's of great interest to designers is natural language processing. How to understand what humans say. But one of the things, if you study designers and study designing, designers talk a lot. They don't just sketch, build models, build computational simulations. They actually talk. And what they say is an externalization of their thoughts and is used to communicate. And this, the natural language processing, NLP in AI, gives us an entree into that. Something which we don't think about that much is the notion of sensing. You know, humans have 5 senses, and it turns out you can model those. You can mimic them, which is a little different to modeling. And I'll talk a little bit more about that. And of course, that brings us to robotics, which is the embodiment of this. Instead of sitting inside a computer that's physically located somewhere, you can put it inside a computer, inside a device that can act. And that's how we get to robotics. And we've seen a lot of this in construction. The one that I want to talk a little bit more about is learning. Now, humans learn all the time. They're taught. You go to school, you go to university, you can learn intentionally, you can read textbooks. You can also learn unintentionally, simply by doing things in the world. And that has opened up lots of ideas for AI researchers in learning. But as is often the case, computational systems are built with capabilities way beyond that of humans. And we'll talk very briefly about that. And there's many more. So where do we see this going in design? So one of the areas is cognitive agents. So an agent is a semi-autonomous computer program. Say an Excel spreadsheet is not autonomous in any way. You have to start it, you have to fill it in. It doesn't do anything beyond exactly every time you ask it to do something. An agent has capabilities way beyond that. It has some autonomy. And today, the cutting edge of this is cognitive agents. Cognitive meaning built on ideas associated with how the human mind works. And then the other big topic today is deep learning. So I want to talk about these two a little bit. So what do we mean by cognitive, and what does a computational agent look like? And this is a simplified version. Don't spend too much time reading it, but basically it's a system that interacts with what's around it. So what can be around it? It can be the world, it can be other agents, it can be humans. And it has the kind of capabilities that humans have, which is they can sense things, they can build perceptions, and they build concepts. And out of that, they make proposals and put forward ideas, which they then put out into the world. And one of the things that has become very interesting is the notion that in addition to this, agents have social interactions. And by that, I mean social media interactions. So let's see what sort of thing you can produce. So I'm going to show you a little video. And what have we got here? We've got three things. We have red dots, and these are requirements or functions that you want to satisfy. We have components, which are the blue dots, and the lines between them are the interactions that are generated if you put any of these two together. So here's a self-assembling system. And they sometimes generate requirements because of what they do. And in the end, you get a design, I use the word design very loosely, made up of the components that are available that meet as many of the requirements as it can. So this is a model that's automated. The sort of things you can do with this, though, is to study things that are very hard to do. So one of the things that if I'm an organization that has a major design team, and I use that team to develop products in the market, one of the things I'm interested in is how my products, my ideas in those products diffuse in the market. And we can build models of innovation diffusion, which previously we couldn't do at all. So this is at a very different scale. So this is looking at different innovations, how that are competing with each other and how they can dominate. The topic that's probably the most interesting today is deep learning. Deep learning, interesting enough, is not that new. The ideas go back 10, 20 years, but the ability to make use of it has changed dramatically. Today, you don't need to write any code. You can use a number of systems from the cloud. So what is deep learning in relation to design? So, whoops, this is not what I wanted. What does deep learning do? I'm not talking about the technology, but if I'm using it in design, what does it do? And what it does is it builds a parameter space that can be very large, very, very large. And because of that, inside that design space, which is what the parameterization is for a design, you have areas that you don't know about, that you didn't know existed even. So forget about the mechanics. Think of it as it's a technique for taking some examples and building from more and more examples an increasingly multi-dimensional parameterized space that can have extraordinary numbers of parameters. To give you some idea, there's a fantastic, I'll use the word advisedly, system that generates text and responses that has more than 1 billion parameters. 1 billion is a lot. So here's an example, say in fashion design. You have an input shape, you add some noise to this. What happens with these input shapes is it builds this big parameter space. The noise helps to broaden the space, and out of that you can now get, let's call them designs, well, it doesn't think of them as designs, that weren't there. So this again is sort of an automation process, but what it's done in design terms is open up possibilities. That's the interesting part here. And then you can connect that with humans and select out of those, you know, something that might be thought of as the most interesting, the most novel, and drive the system again. So it's a sort of generative system. And you can take that and build a generative system. So this is designing, I use the word designing carefully, designing the chassis for a drone. Where did the data come from? The data came from lots of chassis that were instrumented in a mechanical structural sense, so that we have two things here. We have the physical layout, but we also have the performance. And this might be one point you say, okay, let me start here. And what do I get? This is looking around. Whoops, that's not what I want. This is looking around where I started, given the criteria that I want to satisfy. There are as many designs as you could imagine. The one it produced is on the left, and it's surprisingly close to natural selection in gliding mammals. So it doesn't take much imagination to think that we can do a lot with this. We can, for example, take all the designs we've ever produced and throw them into a deep learning system, and then get it to pull out designs which we didn't produce. But one can do a lot more. One of the complaints about deep learning is that there's no knowledge there. You know, in engineering, we have, starting off with Galileo, Newton, and the last 200 years of engineering science is all thrown away, not used. And that's sort of a shame. But what people have done is to say, let's not stop at just entering the data and pulling out points. Let's enter the data, build this parameterized space, and characterize the space in the way engineers does, which is through algebraic equations. So on the left is flow around a cylinder. We drop that into a deep learning system, and the top one is what it thinks the world looks like. The bottom one is actually the theoretical solution. And when you extract the equations from the deep learned system and compare them with the theory, which is the Navier-Stokes equation, you discover a really, really strong coherence. You know, there's quite small differences between these. So this is quite amazing. You know, Navier-Stokes did it with serious deep thinking, and the deep learned system has none of that. It's a fundamentally different approach. It may be possible to build equations for things that we currently can't imagine building equations for, like human response, where we have no entree into how we can do that. So this opens up possibilities of a kind we didn't imagine. And then we have new kinds of interactions. So here's a robot. It's trying to learn classifications, and a human with, in this case, EEG cap that's scanning the brain, and the human is, without saying anything, thinking this is positive, this is negative. And that's fed back to the robot, and the robot learns by the human thinking. So this leads some people to a notion called the AI singularity. What is that? The AI singularity is when AIs are as capable as humans and have the potential to take over from humans. And that, of course, points us to the AI in design singularity, when AIs are as capable as human designers and have the potential to take over from designing from humans. Well, let's look at this, because these are fundamental questions that need to be answered. The first and most profound one is human activity just the sum of capabilities? Because you can sense, you can reason, you have emotions. Is that what makes up the basic core of how you could possibly live? Or is there something else? The world is truly messy, both outside your head and inside your head. And you end up with these amazing consequences. Here's this robot trying to put this Whoops. So what it's trying to do is just put that there. Why has this failed? It's failed because it doesn't know enough about the world. It didn't know, for example, that right at the end, that it should know about the desk that's behind it, that knocked it down. It didn't know that you should, after you've done something, you should check where your arms are. There's lots and lots of things that you wouldn't expect to program, and it gets worse. So is designing simply a sum of capabilities, or is there more? And the question to ask then is, what makes designing different to just living and to problem solving? And the fundamental idea, of course, is that designing is generative. What do we mean by that? The purpose of designing is to produce something that wasn't there before, whether it's a physical object, a virtual object, a system, which in itself may not even be thought of as an object. Generative. That's a truly important distinction, but there's more than that. Because when you design, you actually create possible design spaces. That is, spaces within which you're going to design. And they vary, that is, the kind of design space or the design space you cognitively work within is a function of you and your experience, the task, the interactions you have, all sorts of things. It's not there waiting to be plucked off a shelf. The goals you design for start off being given to you, but your goals change as you design. And when you study designers, you see this almost every time. It's very rare where the goals that are listed at the beginning are the only goals you talk about. Another idea which is connected to that is this notion of framing and reframing. What you decide to include in the frame that you're looking at is up to you, the designer. And regularly, you reframe what you're doing. And then another fundamental idea, which is designing is situated. Situated means a number of things. It means it's not isolated from anything, which is humans are never isolated from everything. But not just that, you interact with the world, you interact with the world inside your head, and that interaction changes things. We saw the robot just kept on going. The interaction with the world had no effect. And designing means learning while doing. Every time you design, you learn something. And then finally, not even all the criteria you're interested in are given at the outset, because a lot of the criteria are a function of decisions you take. And then what this means is designing is non-monotonic. Decisions taken in the past do not stay taken, fixed. They can be changed by what happens in the future. We do not have AI close to this. So this points to the notion that maybe what we need is humans and AI. And this, for example, is a system, a deep learning system, where you pull out areas of interest, and this is a Pareto surface, and you pick from those and you interact with this AI. Or here's another example where we're using sensing as the interface. We're sensing the emotion of the designer as in a co-creative system to control the AI's path. So you don't say, oh, I like this, I don't like this. You don't say anything. It looks at you, and based on what's the valence of your emotion as to what it does next. So what is the future of AI in design? Well, nobody knows, but here's some thoughts. A question I'm regularly asked is, will design be automated? Will I be out of a job? Well, you might be out of a job, but not because design is automated. Some aspects will be automated. Humans have this amazing propensity to devalue what they do if you can automate it. And there's this huge thrust currently via deep learning to automate everything in sight. But you won't be able to automate design, just some aspects. Will designer augmentation be possible? Absolutely. That's what we expect, that designers will be augmented. And I'll come back to that in a minute. Will co-creation become possible? Co-creation is where the AI takes decisions based on your decisions, and you take decisions based on the AI's decision. A lot of research in this area, and we're beginning to see some systems. So they'll be partners, not tools. They won't be equal partners, but they will be partners. And then there are quite new areas for AI in design. The most obvious one is learning from designers designing. So, we have a system that is used to learn from designers. These are engineers who are using MATLAB to model what they're doing. And it learns about the interaction between the designer and MATLAB such that it creates less friction between the designer and what they do with MATLAB. It sets all the equations up based on what it's seen. It selects the right tool. It fine-tunes the algorithm. This is learning from what the designer has been doing. Whoops, we seem to have. Integrating brain sensing with AIs. And I'll come back to that in a minute. And then, of course, ethics. The thing isn't about ethics. We'll come back to it. The trouble with AI is that we have not yet found how to imbue AIs with ethics. And we have trouble with humans about ethics too, but this is a different issue. And this is a very big research topic at the moment, because it turns out everything humans do is biased, unintentionally, inadvertently, and without knowledge of it happening. And we've already seen examples in AI, particularly in deep learning, where huge mistakes have been made unwittingly by, for example, training face recognition on using the faces of white males. It turns out you do not get good results for non-white males, and you get worse results for females. No one gave any thought to this. And then this is a nice little example. This is real time, integrating brain sensing. And let me show you what it's doing. So this is an $800 EEG cap. And the person is asked to think Zoom. And what they're looking at is this object. And it's now an AI sits behind this, learns the pattern, and now the person thinks Zoom, and the CAD system has now zooms without any external interaction. So we can see from here, there's a lot of dimensions coming along. And let me, stop there and open it up for questions.
Thank you very much, John, for this wide overview, but also quite a number of very intriguing aspects. And I think probably about all of these we pay a presentation. But I think it shows a variety of things. And while people, please ask your questions through chat, I will maybe start with that. You talked about this uniqueness of design, because yes, we can use AI. AI has many opportunities, but there are elements of design that are just still or maybe forever outside of this realm of AI. What I found also intriguing was the patterns. You showed this with this Navier-Stokes equation and this pipe, and that was very similar to what is there. And I had a feeling, well, what it learns, what the system learns, are these patterns. Yeah, as you said, it doesn't have, it learns patterns extremely well. We've taken hundreds of to figure that out. So I was wondering that the thing that it doesn't know is why. And isn't it the why, because if we know why, we can maybe see better where to apply it or try to understand it. Or do we not need the why? It's fine, we know that it works. And if the case, if it's about the patterns and getting the equation, let's say, is it not science that is then a danger? Because science is about knowledge production, isn't it?
Science is not about why.
Yes.
Science is about how.
So maybe it's science who should be frightened for AI.
Yes.
What's your opinion?
Well, this is a big topic in science, particularly, I mean, one of the areas that I know there's been a big push is in biology, where they're trying to build more formal models of biological interactions and microbiological interactions. The trouble, see here in the Navier-Stokes example, we have Navier-Stokes, so we know that it looks right. But if you don't have Navier-Stokes, how do you know it's right? I use the word right in quotes. How do you know it's a good example of how things are connected? How do you know that the variables that you've selected, that the system has selected, because it's got a lot of variables to play with, match those that are going to be useful? Because what they don't show you is there's lots of other equations generated.
Yes.
Right? But it does open the possibility of areas where we don't have formal models to produce formal models.
Mm-hmm. Yeah.
And that's pretty intriguing. Mm-hmm. That you could take, for example, a lot of human behavior and build formal models which could predict what happens without knowing anything about why. And I don't think equations embody why at all. Equations embody how.
Yes, but don't we need why in order to work with it and generate new solutions?
Yes, so we claim something on top of what's in the equation. We claim causality. We don't just say, if you have an A, but then you'll end up with a B. We say A causes B. You cut the skin, that causes blood to flow, through a process. It's causality that is claimed by humans. But causality is always tentative.
Yes.
We don't get causality out of AI, although there are people who claim you can, in the same way humans can, generate causality. One of the problems that is fundamental for AI, which humans don't exhibit, is AIs are always closed in the sense that they look at what's there. Humans can come up with new interpretations of things which aren't there. And we have no examples of how you might do this with an AI. Come up with things that aren't there actually until you make them.
Yeah, or imagine them.
Or imagine them.
Part of this imagination of the future. You showed that robot, and the robot forgot that it had arms. It did.
Yes.
It seemed to have been for the task at hand. And isn't it so that, at least for a long time, that product systems, machines were often developed, the software developed for the particular task without considering what happens if someone forgets something, what happens, without contextualizing it at all. And it almost seems that with these type of programs that you don't show, we're sort of going back to that rather than contextualizing. Would you agree?
Well, I picked an example that showed bad things, of course. Actually, in the world of designing factories and production lines, AI has shifted the boundary. The boundary used to be the production system. And then you built machines that did that, and then a factory that contained it. Well, now, instead of building machines that do the production, you build machines that can do any production, but happen to do this one. And the factory is part of it. So you don't have a factory that only has linear production. It's a factory that can reconfigure itself. So if you had, I don't know what this means, circular production.
Yeah.
So, although I've said lots of negative things about AI, AI is opening up human imagination. It's not the AI imagination, it's human imagination. Another thing that AI misses, which is profound, is that they're not motivated to be more than they're asked to do.
Yeah.
And humans often do much more than you ask them to do. They also
less.
often do less. Right?
Yeah, indeed. Okay, I see. Thanks, John. I see a question here in the chat. Please put your questions in the chat. And here, one of the PhD students here asked, what would be the best suggestion for starting to learn AI from scratch? I'm new to this department, and how can we combine AI mechanical design science, areas like drones, 3D printing. That is what he is interested in. Where would you start?
I would start with a number of things. You can't just do one. I would start off with if there was a book called AI for Dummies, that would be where I would start. To get an idea of the scope of AI, right? So there is a very nice thick book by Russell and Norvig, Norvig, Introduction to Artificial Intelligence. It is a very fine book. And if you skimmed the chapters, that would give you a good entree. I would also look at published papers that review AI in design or areas of AI in design. So if you look in places, well, it depends what area you're in, but if you're in drone design, it probably means mechatronics. So if you go to JMD, the Journal of Mechanical Design, and look for some review papers there, go to a journal called AI EDAM, Artificial Intelligence and Engineering Design and Manufacture. There'll be some papers there. I would also cross over into cognitive science and design, because a lot of AI today borrows ideas from cognitive science. I think you can buy people with the technical skills. You can't buy people with the imagination about what to do. And there aren't books on that, right?
I think that is a good point. It should inspire, and it should think, hey, how can I use these techniques and these ways of working? Yeah. So, any other questions? Oh, the audience is quiet. Yeah, please let the questions come in. Oh, yeah, you mentioned epics. Oh, there's a question. Sorry, I just. So thank you, John, for the suggestion. He appreciates it. Another question came, how different is a complex design optimization algorithm compared with an AI for design algorithm?
Okay. Complex, so any optimization algorithm assumes three things. You know all the variables before you start. That's very restrictive. Not impossibly restrictive, but very restrictive. Secondly, you know all the criteria before you start. And thirdly, you know all the constituent equations that connect the variables together before you start. So extremely powerful once you know all that. But if you're trying to decide, am I going to use this kind of energy or that kind of energy, or maybe some other kind of energy, which I haven't yet thought out. Am I going to have other people come in later and talk to me about things? Optimization doesn't work until you then get to that next step where everything is laid down. Of course, in theory, you could put every variable you ever could imagine, but then you probably don't know the connections between them, the constituent equations. So actually optimization is a very powerful, narrow tool in the toolbox of a designer.
Okay, thank you. I saw another very interesting question, whether I could ask you what you There are now so many coming in. What you would do, or how would you direct your life if you were 20, 30, maybe 40-year-old today? You now know about AI and design, about the current AI and design, because you were at that age when the first wave was there. But even this now, how would you direct your life? So I assume what you would like to do. Mm-hmm.
I think the answer to that is surprisingly simple. Find something in this that you become passionate about, because that will drive you and give you something. It'll make you better at it and a more interesting person at the same time. Don't go for a technology because all technologies get displaced, right? If in the beginning of the 20th century, you made the best cartwheels, 10 years later, nobody cared.
Mm-hmm.
Particularly if you couldn't make the transition to rubber wheels in cars. So if it's just the tech, don't follow the technology for the technology. Certainly you have to follow a technology, but for what it does, not what it is. And always remember, people in other fields have no idea what it is designers do.
Yep. Okay, thank you. Thank you. Another question, how can the element of creativity, effectiveness, and feasibility, so creativity, effectiveness, and feasibility, be judged with AI-produced results in design? So if we get in designing, we use AI, we get result. How can we judge creativity, effectiveness, or feasibility? So
how can we judge?
So how can the element of creativity, effectiveness, and feasibility be judged with AI-produced results?
In exactly the same way you do it with humans, with difficulty. Right? Creativity, this is a very big topic in psychology, cognitive science, and artificial intelligence, and neuroscience. Creativity is one of those topics of continuing interest. AI, people have built systems that perform in ways that produce results that, when assessed, are assessed as being creative. But how do you assess creativity? Which is not an AI question. The way you assess creativity, and there's two paths. One is algorithmically, that means you have to look at the representation of the thing, because algorithms require representations. And the other is socially, humanistically. And typically, if you're even things like large-scale engineering projects, you will have dimensions which engineers aren't accustomed to dealing with, which have to do with creativity and other things like politics. How does it affect the decision makers for public works all end up being political. The AI can't address these. So, long answer to this question. Feasibility, that's easy if you can define it. All right? If it says, here's 100,000 criteria which are expressible in terms of variables, and these are the variables you use, you can then test them. You can test 1 million. But if you don't have these criteria expressible in those variables, it becomes hard. Humans have no problem. Humans have no problem working with close to zero data. AI can't work with close to zero data.
Indeed. Okay.
Right?
Thank you. There are now several questions. So the next question is, the applications of AI in engineering science is a great example of preserving interpretability and structure in AI application. But sadly, I feel this is not the case for most AI applications in design. Okay, so the difference is made here between AI in engineering sciences and AI in design. What are your thoughts on interpretability and AI? Do you think AI interpretability in design can augment humans as the driver of design?
Very clearly, the answer to that is yes. The reason I can say that is we built systems that interpret configurations in ways that humans hadn't thought of, and then use that as a stepping stone to the next phase, the next cycle. Humans are fantastic at finding patterns in anything. You know, there's experiments that if we show you the white noise visual image like you get on a TV set, humans can find things in there. I mean, there's nothing there, they just find them. We're evolved to find patterns, structure in the universe around us. But AIs are better. What they're not good at is knowing which of these is interesting. But they can find patterns of kinds that are amazing. And we've built systems that do this, and humans interact with them. And then based on what the AI found, if the human finds it interesting, they then move in that direction.
Collaboration, it's AI and design.
Yes, yes.
Oh, they're very interesting. Someone who knows your function, behavior, structure ontology. How does—
What a good person.
Yeah, how does AI fits into that FBS model?
Okay, we build AI agents on top of the FBS ontology because as design agents, we find, not unsurprisingly for me, we find the FBS ontology provides a foundational structure which allows us to build agents that are focused on design, because that's how we represent designs and design processes. So if you go to my website and look up publications and look for the author Peresic, P-E-R-E-S-I-C, you will see examples of that. Or if you go back further, but these are more recent, Maria Peresic. Mm-hmm. And she's always the first author.
Okay, wonderful. Oh, very interesting. Someone said this before, AI versus humans. AI will win because human is greedy and will make mistakes. Your view, please. AI versus human. AI will—
well, firstly, I don't think AI versus humans is a question. And let me tell you why. Humans, not surprisingly, are egocentric. Actually, hugely egocentric, both individually and as humanity generally. When an AI has a capability that a human has, and then that capability exceeds what the human does, the human devalues it. So what? You know, when I was in high school, which is a truly long time ago, there used to be other high school kids who would come around and put on a show multiplying 2 4-digit numbers together in their heads. Now they would ask someone to call out one number and someone else call out another number, and they would go, this is the answer. We're all doing it by longhand. And today we would think that's just uninteresting. not worth doing, right? Why? Because we've automated it. So anything we automate, we reduce in value. I mean, writing beautiful script fonts was an art form of high value. Today, you know, there's literally 10,000 to choose from. You know, you just choose. There's nothing valuable about it. So that's where the distinction is. It's not, here's AI, here's humans, and things happen. What happens is AI expands, humans move. AI expands, humans move. Mm-hmm. So the question is actually not posed understanding that. So will we get robots that are much more in reasoning capacity than we have now? Yes. Will they do things which we're not able to do? Yes. Will they upset us? Probably yes. Right? We already see it. You know, if you've ever tried a Tesla in self-driving mode, a lot of people are quite shocked. They will not take their hand off the wheel. Right? Although statistically, you're much more likely to die with your hand on the wheel than off the wheel. Right? So it's not a fixed target. It's a moving target. And that's, I think, brings us to this fundamental issue about humans. Humans have this capacity to adapt. And not just, you know, you damage your right hand and you're a right-handed person, you learn to be left-handed. But your brain has this amazing capacity to adapt what it does in different places. So if you get brain damage here, now, actually, that's not a good example, that's very hard, but back here, and that part's damaged, another part takes over doing that. Maybe not quite as well. Now, people who've had strokes and have destroyed part of their brain, they relearn, it's not through that part, another part. It's called plasticity. The other thing is that, you know, everybody's brain is different. Some bigger, some smaller physically, yet everyone is sort of the same as well. Each person has this a sort of special capacity. And the other thing we find, and we're sort of shifting off AI, but humans constantly generate neurons, even at our age. The difference is that if the neurons are not needed, they die. Whereas when you're 18, you're still coming up with, your brain is required to do things you haven't done before. And the neurons that are generated are co-opted and therefore used. So humans are not fixed. AI is fixed. Now people say, okay, but we can make AI learn. Yeah, but it can only learn from the past always. And it doesn't know what to learn. And it doesn't know what to, when I say what to learn, I don't mean it doesn't do all this stuff that deep learning does, but of all the things it could do with that, there's nothing there to tell you what to do. So this distinction between humans and AI is quite profound. Now, does this mean never? The answer to that is you should never say never, right? I don't know, but are we close to an AI in design singularity? Not at all, not at all. Are we close to making design look different? Yes, definitely.
Okay. Yeah, I think with that you already also answered some of the other questions in
Oh, sorry.
no, that's fine. That's fine because it's already past 5. One thing related to what you just said, isn't also a thing that you said with the flexibility. A human can change its behavior, what it does. With one case, it only needs one case. Or
One case.
need a case. I can just decide.
Well, it doesn't even need a case. You're right.
Yeah. Whereas AI would need to recognize patterns in something that happened. So it's always a bit late and it needs much more.
But, you know, my AI, heavy AI colleagues would say, I can build an AI that's based on one case.
Yeah, okay.
Maybe. We don't know how to do it yet, but, you know.
Yeah.
Sure.
So there was because I said there were a few questions about whether AI could take over humans completely. So I think you've addressed that to point. But is there any chance for AI to fail? I assume the question is for the field of AI to fail. Has AI failed at any circumstances? There are examples.
The answer to that is unfortunately yes.
Yeah. Mm.
And the biggest failure for any system, particularly an autonomous system, is that the situatedness of the system. It doesn't know about something that then affects it. Yeah. And we see this in robots. You know, the Defense Department funds a huge amount of robotic research and then has these grand challenges. And these multi-million-dollar research endeavors and tens of millions of dollars, which are asked to do something relatively simple, suddenly fall over. Why? Because the door has a 2 centimeter threshold. And it hasn't dealt with thresholds in doors. Yeah. Well, that's, you know, simple things like that. I mean, the robot example I gave you was full of that, a complete lack of situational awareness. Now, of course, this is a very big research topic and very interesting because, you know, the next generation of, say, personal assistants on your phone, there's a lot of research to give them situational awareness, like to know what it is you're actually doing. You know, if you're in the bathroom, turn the camera off. Right? But how does it know you're in the bathroom? Well, the bathroom has a special sound. And so there's a lot of research on what is the sound signature of different spaces. So that, and you can put that in the AI now. But, you know, when something new comes up that's not in there, it doesn't know of its existence. That's the problem, right? I always, in the little video clip I showed, it didn't even know that the table was behind it because its vision system was told, look at where you're going to put this. It wasn't told, look around. And because it was obscured, you know, all those bad things happened. So that's the failing of AI. Again, my AI friends will say, no, give us more money and we'll put that in too. Not as straightforward though.
But also I think Peter Jan Stafford, he mentioned more about observations cover only what is. And that comes back to what you said earlier, this imagination of, you know, maybe this, at the moment there is nothing there, but there is something seems to come in that direction, but it's not how the whole imagination, I think that is different. And when we design projects, we are talking about situations that do not exist yet, the situation in which your solution will work. Yeah?
Yeah.
We don't know. Yeah? It doesn't.
So there's a fundamental thing, and I sort of alluded to it in the talk, not consciously, but unconsciously. Designers work within a space of ideas. And every time they add something, you know, there's more possibilities in that space. AI could model that if it knew all the things to add, but it doesn't. And it can't, fundamentally, unless it knew about everything. And, you know, that's asking a lot.
Okay, I just, it's nearly 5:15. Just one last question. I hope I understand. I'll just read what it says. Maybe you can make sense. Could AI start designing human behavior to the level that its natural behavior becomes obsolete? For instance, as in online social behavior. Could AI start designing human behavior to the level that behavior?
This is a very intriguing question because it addresses a circularity. The answer is you could create a system, and so you create a system that designs human behavior and produces new kinds of behaviors, let's call them human behaviors, new kinds of behaviors, which are emergent. There's always the problem here is that when an AI produces something it didn't know it was producing, it doesn't know it's there. So this is a sort of circular problem. So now you have to give it the capability of finding things that it didn't know were there. Humans do this naturally because of their the way they structure the world around them. You can give this to an AI. The trouble is you can't give it the breadth that humans have. So you could say, look for shapes that you didn't put there, right? So that the famous example is if you take two squares and overlap them, you get a third square, a small square, right? Sure, you can get an AI that does that. Actually, we built systems that find those. But what happens if I'm looking for, if there's something else happening, like symmetry? Okay, maybe you can find symmetry. What about line thickness? How does it, why would it look at line thickness? No, two squares overlap so close that it's one square that's with a thicker line. So humans perceive that, and then they have a concept to talk about it. These are tough problems for AI. And these are trivial problems compared to something richer.
Okay, thanks very much. Thanks everyone for all the questions that you have asked and for all being there. So it's always a bit boring. We can clap, but I clap for the others, at least hear my sound.
Thank you.
Thanks very much, John. I think there was a wealth of very interesting points in your talk that will happen for many more years to come. And I'm sure there are research projects I hope will, that it will have stimulated people to think beyond just the method and the tool that AI is, or process that design is, and start seeing how we can maybe benefit from that thinking. I also think that you showed us a way of thinking about the topic, and that is also very important. I know there are a lot of students also online. I saw that, and I hope they too learn. So thanks again. Many, many thanks, John, for a wonderful talk. I would just like to end for the audience to highlight the next two talks in this series on AI and the future of design. On the 10th of March, paradigm shift to natural user interfaces. That's someone, the product lead at Google, who talks about that, Yarif Adan. And on the 1st of April, how AI can benefit from great design by Min Dao, and that he is in the Federation University Australia, at Canada for Australia, I meant. And over the summer, John also raised that this ethics. Over the summer, we're currently preparing our next series of 3 on ethics in design. And I hope, of course, to see you in all future ones. So thanks again, everyone. And, you know, for second time, thanks very much, John. Wonderful afternoon. And
thank you.
Wish you all the best. Don't get.
Bye.
Okay, bye. Thanks, John.